You got me learning. Oh, I thought you were going to sing the next part. Oh, you're muted. You muted yourself, honey bunny.
You know why it is? Because I
I'm
was trying to use my
learning.
paper as the microphone. So, since that's not on the screen right
Oh,
now,
yeah.
that's why.
Okay, good. Okay, good. Good. Well, welcome back, all of us.
Welcome back,
Me and look
everybody.
at
Good to
Jacob
be
got
back
a
here
new
again.
haircut.
You
Jacob
dyed
got
your
a haircut.
hair.
I dyed my hair and I literally just
Woo!
took some of it and just chopped it so it's a little more layered. So it
I
feels like
like
I
it.
got a new haircut, but really it just took me 5 seconds. But good.
Looks
We're
nice.
all fresh. Thank you. Yours looks great too. You look all like ready to take this on.
That's right.
Cool. Hi Jane. Hi Traveltology. I just saw you pop in. Did you see this weird? Is this a troll thing or is this a actual thing?
No, no, no. Yeah. So this is over of
I was like, I
is
don't think
X
it's a
over
troll.
100.
Uh,
And
okay,
can
so
you
I
go
realized
ahead?
that. So sorry, I asked you a question and then I interrupted you. I want to go over the is over at over that because not to be confusing, but I feel a little confused. I don't feel secure on that.
Sure. Yeah, we can
And
definitely
so
do
even
that.
when like I should be able to get that is what's the slash for?
I'll explain that. What I think is going to help if you bring up my paper,
Oh,
and
okay.
then
Sorry.
I'm going to
So
fix
the,
my
some of this
mic.
is ahead of stuff that we haven't gone through yet. Is that
No, no,
why?
no, it is.
Oh, okay.
But really, because I want to be able to show it on my paper, and then also because I was hearing my own voice delayed in my ears, so that was making me a little bit crazy. So now I can actually use the correct mic.
Okay,
The
cool.
truth is, in the future, once I don't have the paper up, I can take my AirPods out. I feel silly that this is such a thing every time we stream that I have to figure out my audio when I'm streaming on two different devices. I
No,
might
it's
invest
totally
in.
fine.
It's
It's
working
totally
out.
fine. It's
Nice.
absolutely fine. And actually, someone commented in the YouTube comments after the
Hmm.
videos
Oh
that they
yeah.
actually like when we do separate screens because they can see it. They can see really well what you're talking about, and they can see me and you. So they actually like it when we're not together, even that's not very nice. Even though
No, and
we
the truth
like to
is,
hang out.
I might also look into investing in something like a document camera where like in the classroom, we have one in my classroom, but because that's the property of the district, using that for streaming wouldn't necessarily be the most professional thing in the world. But if I were to invest in something like a document camera for myself, where that way I could share my screen and then my computer would be hooked up to a camera that's focused directly on what's in
Right.
front of me, it could be like
Totally.
this, like what I've got here, except maybe
You know
just
who does
a little
that?
bit less complicated. Yeah.
Who you could talk to about that actually is Dan Walks LA because
Okay.
he kind of draws and does stuff, and so he likes to share sometimes multiple screens, and so I'm sure he's just smart with that stuff. So I'm sure you computer expertise could figure it out really quick.
Oh yeah,
But
totally. Do you want to go ahead and pull up James Smith's comment on the screen so that we can see it again?
yes, hi James.
So he's bringing up this formula that
And
we
I
were
meant
looking
like,
at.
is he trolling in a funny way, not in a toxic way? I was just like, I'm not sure if this
Yeah.
is like a funny troll thing or
No, no, no. It looks like he's actually kind of given us a warm-up problem that we can start
okay.
with because this is also
Yeah, so
related
I
to
was
what
gonna
we were
say,
doing
should I
yesterday.
try to okay, perfect.
All right, so what I'm going to write here as just a formula that we can use as a starting point for a lot of these types of questions is over of equals. He put a question mark over 100. I'm actually going to put percent over 100 because
Sorry.
anytime that we are
I was trying to
anytime
see if we could make it bigger, but we can't. We've already tried that a million times. Okay, sorry. I'm fully listening right now.
nice.
Right now. Right now. Right now.
So
Okay, boom.
can't with you. I'm joking. I'm joking. Anytime that we're working with numbers where we are asked what percentage of this number is this number, we can use this formula to determine that. So with the example problem that we're looking at here, what he asks is what is 5% of 36? So the total number right here, what is the total that we're calculating a percentage of? I'm not even going to copy down this part of the question right here. What is
5%
5%
of 36.
of 36?
And so,
So what is the big number that we are calculating a percentage of?
what is the big number that we're calculating a percentage of?
Yeah, like the total number. We want to find
36.
36, exactly. So
Yeah.
36, because it appears right after the word of, and it's that big number that we're calculating a percentage of, that's going to plug
Oh,
in right
15%
here.
will
So plugging
become,
in, yeah, writing it, rewriting our values in the context of this formula right here.
uh-huh.
On the bottom of that first fraction is going to be 36. And then what is the percentage that we're working with in this question?
100. Oh,
Mm,
sorry, 5%. I thought you meant, yeah. Okay, so
yeah.
5%.
Yeah, so 5 is going to go right here.
I can't see the total
Oh,
bottom.
sorry.
Yeah,
Here's this
there.
up.
Yeah, that's why I
So,
said 100. Okay.
nice. So, what we don't know is what is 5% of 100. So, is, which we see right here, is the missing value. So, I'm just going to put x right here. Now, with these values, we are solving for x. And now, a couple of other things that I think it would be good to pause and just make sure that we understand before we go on. Do you understand that any percentage can be rewritten as that number, whatever the percentage is, over 100? As in 5% equals 5 over 100. 16% equals 16 over 100.
Yeah.
79% equals 79 over 100. Like that's just another way that we can express
Yeah. So it's
percentages.
always going to do 100.
Hmm. So fractions are also, if we know that these two fractions are equal to each other, we've gone over like looking at common denominators or least common multiples so that we can change the values of fraction, or excuse me, change the ways that fractions are represented without actually changing the value of the fraction. So what we're looking at here is we're looking at two fractions that are equal to each other. So we want to figure out if, because we know that if we do the same thing, like multiply or divide by the same amount on the top and the bottom, the value of the fraction doesn't change. It's just the way that it's expressed will change. So we need to
Yeah.
figure out what value can be plugged in right here so that this fraction, x over 36, is equal to 5 over 100. So that's a
Okay.
way that we can write out what is 5% of 36 in a formula that we can use to solve for the answer. So
Hmm.
before we go on, is this making sense so far?
Almost. Yeah. I think I just have to do it now. And then
Okay,
it will like seal the deal.
nice. So the next step that I would do here is I would cross multiply. So in cross multiplying, I would now multiply the top left or the numerator in our first fraction by the denominator in our second fraction, and also vice versa. The denominator in our first fraction is going to be multiplied by the numerator in our second fraction. So 100 times x. How are we going to write that when we're now setting our cross multiply values equal to each other? What is 100 times x? How are we going to write that?
100 at the bottom and then X at the top.
Actually, no, because these are essentially both going to be fractions over 1. It's not going to be expressed as a fraction anymore. 100 times x is just going to be written as 100x. Are you following me?
X is just going to be written as 100.
It's a number that appears right before a variable or a letter that's representing a number, which in this case is X. This number is called the coefficient. Now, that's not super important for you to remember that, but 100x means 100 times x. So if it said 50x, that would mean 50 times x. So now, once we solve for what's on the other side, we're going to divide this by x. 100x divided by 100 is going to leave us with x. I think maybe if we finish the problem, then it
Yeah,
might help to just
it's
finish the
not
problem and then
syncing.
come back and go over it again. But
Yeah.
100 times x is 100x. Now, on the other side of the equal sign is going to be 36 times 5. Be able to solve that? 36 times 5. You can even use a calculator if you want. I mean, you can solve it out, but if you want to use the calculator now that you have it, you can.
I just want to know it so I can figure out how the explanation of what you. I don't want my mind to think about this when I'm trying to think about other things.
Sure. So it looks like it's going to be 180. I can just double
Yeah,
check that really quick.
yeah, 180. Okay,
Wait, yes,
it is.
great. All right, so
Oh,
now, because
hold
we
on.
just
Let me turn
crossed.
on the AC since I've been not using the AC.
Mhm.
Okay, sorry.
No worries. All right, so now, because we cross multiplied, we now have our values expressed as 100x equals 180. So our last step here would be to solve for x. So in order to solve for x, we want to get x by itself on one side of the equation so that this equation is simplified to just say x equals blank. Does that make sense?
Time.
All right. What I'm going to do, and I didn't do it like this yesterday, I'm actually going to rewrite what we see here one more time so that the next step might be a little bit easier to follow. So we have 100x equals 180. In order to isolate x and get it by itself, I was kind of just saying this, but what we need to do is divide both sides by 100. If we divide both sides by the same value, then the equation will continue to be true. So now our answer, and I know I'm running out of room a little bit here, but our answer is now going to just read x equals, because the hundreds cancel each other out right here, 180 divided by 100. So 180 divided by 100 is going to be 1.8. Anytime that we're dividing a number by 100, we can just move the decimal point 2 spaces back. So 180, the decimal point is right here after the 0. Moving that back 2 places is going to give us 1.8. So our question initially was, what is 5% of 36? Our answer would be 1.8. How are you doing? Did you follow along? Do you feel like you want to go through it again? How do you feel?
Um, I feel like I don't know if it's. So then where would you put the 1.8? Above the 36?
Yeah, so because we were solving for that is in that equation, is over of equals percent over 100, that is would be 1.8. And that fits into our question where we had what is 5% of
Oh, so
36?
5%.
1.8. So I can even
Right.
put that back up here as our answer, that 1.8 is 5%
Or
of
1.8. Yeah.
36.
Is 5% of 36. Yeah.
Another thing that I think it would be helpful if I do is up here, I didn't really explicitly go over like the steps to follow in this equation after going over is over of equals percent over 100. So if I were to write those out as steps, I would say step one is over of equals, I don't know how well you can see that. I might need to move it down. Equals percent over 100. Step 2 is cross multiply. And then after you two
Your
products
audio keeps
equal.
I Jacob, your audio keeps cutting in and out. I think
Oh,
you
is that
just
right?
keep hitting I think you keep hitting the wire or something with your paper right there on your computer. That
I
goes in your
think
headphones or something.
I think also
Because
my
it
compute. How is it right now?
it's
Is it okay?
fine sometimes, but when you move back or something, it like kind of goes out a little bit.
Okay. I think part of what might be happening is
Whew.
that my computer might be getting confused and wanting to connect to my AirPods because I do connect with my AirPods sometimes to my computer and also sometimes to my phone. So I want it to be to my phone right now, but I think my computer keeps also wanting to connect. That might be it. I'm not sure.
Yeah.
I'll try to
Okay.
be mindful of it. But
Yeah. Yeah.
let me move this down a little bit so that you can see the steps a little bit better. So step 1 is over of equals percent over 100. Step 2 would be cross multiply, which means multiply the numerator of one by the denominator of the other and vice versa. And then once you cross multiply, you set those products equal to one another. So the first numerator and the second denominator, their product, which in this case is 100x, is going to be set equal to the first denominator and the second numerator, their product, which in this case was 180. So set products equal to one another. And then step 3, solve for any time that you receive a problem that's missing any one of these values. If it, because you could be asked what is 5% of 36, you could be asked what percent of 36 is 1.8, and then we would just plug in the values differently. If that was the question, and the question was what percent of 36 is 1.8, then we would put the 1.8 right here where the is goes, 1.8 over 36, and it's the percent that we'd be solving for, and so that would be the x that we're looking for. But once we cross multiply and set products equal to one another, then there's going to be one value that you don't have that you're looking for, and so that's what you'll solve for, and you'll simplify the equation so that you're left with x equals whatever your value is. How did that make sense? How did that feel?
I don't know. I feel like I get some of it, and then I feel like I'm like I feel like I forget everything that we went over.
I know it is a lot that we're going through, and actually, there is a whole proportions and ratios and percentages lesson that we haven't even gotten to yet. I think that part of what might be a little bit confusing is that we started working with the calculator yesterday, and I actually feel like we did some good work with the calculator and we learned how to do some things that are good to know. But
Yeah.
I think that part of what might be confusing is that we've gone over some concepts on the calculator that we haven't even really gone over a whole lot on paper yet. And I feel like it's good to be familiar with the concepts and be familiar with how to do these types of problems and what they mean. Well, but also that said, it's not bad that we've already got some experience with the calculator now, because I feel like now it will be good to continue going through the additional lessons that we have. And
Yeah.
then after we go through more lessons, then we can come back and return to the calculator and kind of maybe some things that we've learned on the calculator are gonna make some more sense
Okay.
once we
And
go
so
through more lessons.
maybe we can come back to that problem because I feel like that's too much right now for me.
That's okay. I
I feel
would
like we can
recommend.
continue doing what we are doing in our GD. Sorry, James, but your problem is a little too complicated for my brain at the moment.
Working on yesterday. So it is good for us to have some familiarity with. And I would recommend even if you just want to if you'd prefer to just like take a screenshot or something, that's fine. But I would recommend that you have these steps handy somewhere, where anytime that you're working with a problem that involves two numbers and what percent one is of another, being familiar with this formula of is over of equals percent over 100 is going to be good to be familiar with. And then the steps that I've written out here are: step one, is over of equals percent over 100. Step two, cross multiply set products equal to one another. So is times 100 equals of times percent. One of those values is going to be an X. And then step three, solve for X, and that will be your missing value. I think that if you have these three steps handy somewhere, that will be good. If you'd
I do
prefer not
right
to,
here on the YouTube.
okay, sounds good, sounds good. All right, so then would you prefer to go ahead and start looking at the next lesson then after the
Yeah,
nice. So for this one, you might need to remind me where we are because we finished up lesson three, which was all about the calculator proficiency yesterday. So lesson
yeah,
four is all about word problems. And I know that we did some of the word problems, but not all of them. I can't
yeah.
remember where
We
we left
finished
off.
page we finished page 229 and we were
Nice.
going to get into multi-step word problems.
Oh, okay, nice. So this is page 230. Let me go ahead
Well,
and
yeah,
pull that up here. And oops, it looks like I spilled some coffee on my book. That's okay.
I'm
I'll
telling the
live.
teacher.
You're looking at him.
That
All
reminds
right.
me of my chocolate milk.
I'm
Such
gonna
a
drink some
kid.
water for now. Oh yeah, I used to love chocolate milk before school on days we had late start. That was a thing. Sometimes this is still standard. Some schools will do late start and some schools will do early out, but most schools 1 day a week the students have either late start or early out, meaning that if school is usually 6.5 hours, 1 day a week, it might be 4.5 hours. And at my school I work at now, we have early out 1 day a week, where then the teachers have to stay afterward have to stay still their normal, the length of their normal school day for a professional development session or staff meeting or whatever it may be for that week. But when I was a student, when I was in middle school, rather than rather than early out, we had late start. So usually school started at 8:45, but on Thursdays it would start at 9:45. So I would sometimes
And
meet up
you
with my
drink
friends
your
at the bagel shop before
chocolate
school
milk.
and get some chocolate milk. Yeah.
That's
So
cute.
thinking about when I think of chocolate milk, I do think of being a student in middle school. So you drinking your chocolate milk reminded me of that a little bit.
Yeah, yeah. Good, good.
All right, you ready to jump into multi-step word problems?
Yeah,
All right.
I hope
Multi
so. I was feeling very exhausted by that James problem. I don't know why. Like my brain isn't working. Maybe if I start doing these questions, it'll start working again.
Oh yeah, we'll get there. And like I said, we haven't even covered the lesson on proportions and ratios and percentages. And so once we do go through that lesson, I think things are going to start to click more. The way that we're going through it now, we're kind of bouncing around a lot and just being exposed to a lot all at once. So I think that having some exposure to that problem is going to make it so that now, when we do eventually get to the full lesson on ratios, percentages, and proportions, you'll already have some foundation and things will just start to click in a little bit more. I really do believe that.
Okay,
But in any
cool.
case, we can go ahead and focus on the multi-step word problems for now. Multi-step word problems. The word problems on the previous two pages involved only one operation to solve. However, on the GED mathematical reasoning test and other tests, you may need to do several math processes to solve a problem. These are called multi-step problems. When you are working on multi-step problems, there are two important ideas to keep in mind. What is the question asking me to find? And did I answer the question? Review this example of a multi-step
Wait, I want to
problem.
underline that. Sorry,
Yeah,
even
yeah,
though
yeah,
it's
go for
all.
it.
What do you call that when it's already like slanted or has like a
Italicized?
emphasis? Is
Yeah,
that what
yeah,
it's
yeah.
called? Italicized?
Yeah.
Italicized.
So
Okay.
yeah, what is the question asking me to find? And did I answer the
And did
question?
I answer the question? What is, okay. Because, yeah, I first need to find out what is the question asking me to find to know what math I need to do. And then did I answer the question?
Very good.
Okay.
So
Review this
review.
example. Oh, sorry.
You want to read it? You can.
Review this example of a multi-step problem and the problem-solving process below. Example 1. To win a prize, Sarah's daughter... Oh, I need my book. To win a prize, Sarah's daughter has to sell 75 boxes of cookies in 3 days. If she sold 16 boxes on one day and 34 boxes on day 2, on day 1, and 34 boxes on day 2, how many boxes would she need to sell on day 3 to win the prize? Oh, okay. So I'm just gonna... Okay, so what I'm doing is I'm what is the question asking me to find? And I'm finding that it's asking me to subtract. First, add the 2 and then see what the difference is between 75. See,
So
it cut
yeah,
out.
that's exactly right. It cut out
Your
for a
audio
sec.
cut out just when you just started talking a little. It had to like catch on that you were talking.
Gotcha. But you can hear me
Anyways,
now.
but it's still good. Yeah. Now that you're on. I feel
Nice,
like I should
nice.
move my media thing so that, or should I do a radio? Yeah, so I could see your eyeballs when I know I'm wrong. Okay, cool. Oh, sorry. See, it cut out again. Okay, go ahead.
So what you would want to do is, if you know how much is being sold on days 1 and 2, then yes, you would want to add those two together and find the difference between that value and 75. So I would probably write that out as
Yes, so
75
Sarah's
minus,
daughter has to
and then
sell
in
75
parentheses,
boxes of cookies in 3 days. 75 in 3 days. If she sold 16 boxes on day 1, so 16, and 34 boxes on day 2, so 34, so that's 10, 3, 4, 5, that's 50. How many boxes would she need to sell on day 3 to win the prize? 25. Answer is number 2.
good. 75 minus 50 equals 25. Great work. So you totally understood that one. That was awesome. So in fact,
But
you want to,
I understood it, but I didn't do the problem solving the way, because I just kind of already knew it.
and that's fine. If you understand it conceptually to the point that you're able to figure it out without plugging it into a formula, I do think that's going to be okay in some settings. If you want, we can go ahead and read through the steps the way that they solve them out in the book. But if you feel like you understood this one and you'd rather move on to a different one, and just
Oh,
get
I
into the
see.
practice, we could do that too. Do
Okay,
you
let
want
me
to?
read it.
Okay, sounds good.
Step 1, so yeah, I did that. What is the question asking me to find? The question asked me to find how many boxes Sarah's daughter needs to sell on the 3rd day to make her goal of 75 boxes. What information from the problem do I need? I know the total number of boxes she needs to sell, 75 boxes. I know how many boxes she sold on day 1, 16, and day 2, 34. Step 3, do I need to do only one operation or do I need to do more than one? I need to do 2. I can add to find out how many boxes Sarah's daughter has sold so far. 16 plus 34. That's what I did. 16 plus
Hmm.
34 equals 50. However, that doesn't tell me how many boxes she needs to sell on day 3. I need one more step. What is my solution? 75 boxes total minus 50 boxes sold equals 25 boxes for day 3. The correct answer is 225. Step 5, does my answer make sense? Did I answer the question? By taking the additional step, I answer the question of how many boxes need to be sold on day 3. This sample multi-step problem involved only 2 operations, adding and subtracting. On the actual test, you may need to do 3 or more operations to answer a question. So read and think carefully about each problem. As you think about the example, note the most common mistake people make with multi-step problems, often they stop short of answering the question. Notice that the choice 3, 50 is a partial, right? Because some people think, oh, I got it, 50, and then they don't realize, yeah. But it's not the answer to the question. Using the 5-step problem solving process will help you avoid these mistakes. Okay, good. Practice 4.2. Audio, check, check.
Yep. How is it?
Okay, good.
All right. Let me also move my book so that we can get the best view I can manage of these first few questions. So, practice 4.2. Questions 1 through 3 are based on the information below. Farhana's Produce Company distributes to several restaurants. The table below shows how many cases of different produce each restaurant ordered from Farhana's company in July. So we've got restaurants A through E represented in our rows, and then we've got each piece of produce, asparagus, Boston lettuce, carrots, romaine lettuce, and tomatoes represented in our columns. So do you understand how you would read and interpret this graph? Like if I were to
Yes.
ask you how many produce orders did restaurant B order of Boston lettuce?
4.
Let's go ahead and look at question 1. All of the questions we're about to look at are going to be based on this
Wait,
table.
I didn't hear you. Did
I
you
just
say
said
correct?
good. Yes, yes, yes. That was correct. 4 is right.
See, it cut out. I don't like that. Maybe you should take off the Bluetooth.
Okay.
Because it's really annoying because I can't hear when you said yes or no, and that's super important for my immediate knowledge. Sorry, kids watching in the class. I just get really irritated when I'm like, my brain's on a roll, and then I have to stop thinking to be like, wait, did he say yes or no? And then it's an audio thing, and it's like, and then I can't think about what I was thinking about.
All right. How is it now? Is it okay?
It's really good. You're a little loud, but it's really good. So if you want to turn yourself down, then that's fine.
Okay. Sounds good. Okay. So
I wonder
looking
if
at
I
number
can turn
one,
you down a little bit. Hold on, let me see.
you going to turn me down?
Just a teeny bit, so you're not so loud.
Sounds good.
Am I able to do that?
Hmm.
I
I'm
think I
not
can
sure.
only mute. I think I can only mute you. But you're good. Just remember you're loud, so you don't have to be so close to the mic.
Okay. I'll keep that in
Yeah,
mind.
perfect.
Okay. Looking at number one.
Okay,
If
so I
Boston,
was right. When you said restaurant B and you said Boston lettuce, it was
yep,
4, right? Column 2, number 4? Okay,
that is correct. Yes. Good
perfect.
job.
Okay. Now I feel, but oh my God, I feel like I can hear you a zillion times percenting. Okay, just kidding.
Very good. Good to know. All right. Number one. If Boston lettuce costs $17 per case and romaine lettuce costs $23 per case, how much did Restaurant D spend on lettuce ordered from Farhana in July?
Okay, hold on. So what I'm going to do here is I'm going to, if Boston lettuce costs $17 per case, Boston lettuce, okay, and romaine lettuce costs 23. It's here, okay. How much did restaurant D? Okay, we're talking about restaurant D here.
Mm-hmm.
So we're talking about restaurant D spend on lettuce ordered from Farhana in July.
That's right.
Okay. And when they say lettuce, they're talking about never mind. I thought there was more lettuces. Okay, good.
There
Okay,
are.
so what?
So there's Boston lettuce and romaine lettuce.
No, I know. I thought it was more than that. Okay.
Okay.
Okay, so restaurant D. So what I'm gonna do is multiply 7 if Boston lettuce costs $17 per case. So I'm going to do 17 times 2,
Mm-hmm.
which is 20, no, 30. Oh my God, just do the math, Laura. 14, 34.
That's right.
Okay, and then romaine lettuce is 23 times 3.
Mm-hmm.
So that's 69.
That's right.
And so then I would add 69 plus 34.
Yep.
And the answer is 103.
Very good.
So that would be C, 103.
That is correct. Very good job.
Woo! Woo! Applause, applause.
You did it.
We need to hear an applause.
Very nice. Good job.
Okay, good. So now, number 2, delivery costs $2 per case for the first 5 cases. Ooh, and $1 per case for each additional case of produce. What was restaurant B? What was restaurant B's delivery charge in July? All right, restaurant B, delivery costs. Okay, delivery costs $2 per case. $2 per case for the first 5 cases. For a produce. What was restaurant B's delivery? Oh, so at all the cases.
All the cases. That's right.
Okay. Mm-hmm. Okay. So delivery costs $2 per case for the first 5 cases.
So if we're talking about all the cases, then what's a number that we want to know in order to be able to solve this problem? Yeah. So how many? First. So what is the total?
For all the cases, it is 13.
Very good. 4 plus 4 plus 2 plus 2 plus 1 is going to give us 13. So total is 13 cases. So now that's a piece of information that we need to solve. So now
then I do 2 times. First, I'm going to do 2 times 13. Actually, first, let me just finish. Okay. Delivery costs $2 per case for the first 5 cases and $1 per case for each additional case of produce. Okay. So total cases was 13. Anything above 13 is 8. Anything above 5 is 8. Right?
So I see what you're saying. So because 13 is 5 plus 8.
So it's going to be.
That means those first 5 are all going to be 2. Is that
yes?
And then everything else is just going to be 1.
Is going to be $1.
Yeah. So those first 5 are going to be 2. And then the last 8 are going to be 1.
Yeah. And then it says, how much did restaurant D spend on lettuce orders? Oh, whoops, sorry. Delivery costs 2 per case for the first 5 cases and 1 per case for each additional case of produce. What was restaurant D? Okay, good. So that's all. Okay, so the answer to this number is 5 times 2.
What's 5 times 2?
10.
Good.
And then 8 times 1. So delivery charges would be $18, which is letter B.
Very good job. You got it.
Okay, number 3. If asparagus,
are you showing your work on your paper too, or are you mostly just kind of figuring it out in your head?
I'm doing it, but like sometimes I do some of it in my head, so I'm just writing 1, 2, and then so that's all. But yeah, I get you. It's good if I'm doing it in my head. That means, but I'm not doing I don't need to do it enough where I need to do, the problem. I don't need to write out the. Well, I do write out my multiplication.
That's good. That's good.
But the rest is easy for me.
Okay. No, yeah, I generally think it is a good idea to just make sure that you're practicing putting out your thoughts. But I mean, if you feel like you get it and you're able to figure it out in your head, I get you there too. That's cool.
Okay, let's go to number 3. Plus, I bet you it's going to start making me do stuff where I have to do that anyway. So my ability of writing it will get better in that way, even if I'm trying to avoid it.
That's the truth. All right.
Okay. If it's number 3. Hi, Erie. You didn't miss 7 because it's always there. We're on 8 now, but yes, we're strimming along. Congratulations on doing this, Laura. Thank you, Abnormally Normal. I like that. 1219. Hi, Lupita. Hi, Swancho. Okay, back to work. Okay, boom. Next problem. Number 3. If asparagus costs $22 per case and tomatoes cost $15, okay, so already, let me just do that, unless it's going to trick me. Which of the following restaurants spent the most on asparagus and tomatoes combined? Okay, so I do need to do that. So which of restaurant A, B, D, or D? Okay, so basically I need to add them all up.
Yeah, for this one, we are going to need to solve for all 4 of those restaurants. A, B, C, and D. We'll need to add, to multiply and add the values of the tomatoes and asparagus for both of them.
Yes. Let me do it. Okay. So if asparagus costs 22 per case and tomatoes cost 15 per case, which will fall? Okay. So first, okay, so asparagus. Okay, so all the restaurants, asparagus. You know what I'm going to do? I'm going to write restaurant A, restaurant B, restaurant C, restaurant D, and restaurant E, just so I can keep using that. And mark it. Okay, asparagus and tomatoes. Boom shakalaka. Aspare and Tom's. Okay, so restaurant A. So first, I got a little bit harder. So first, I have to. I know you're probably way ahead of me, so I'm not even going to look at you.
That's okay. Did you want to talk it through real quick? I was just kind of starting to solve it out, but I can pause for a sec so we can talk.
If asparagus costs 22 per case and tomatoes cost 15 per case. So first, I need to add up how much. Oh, what's the cover? How much asparagus and tomatoes for restaurant A? So they're both together, the cases. So restaurant A has cases. Oh, total. Restaurant A. Okay, asparagus and tomato. So 5.
I'd be careful about solving it like that. Do you want to look at what I've the way that I wrote it out? I think it might help you, because if you just think of it as 5 cases and you're not looking at the fact that they cost different amounts, that's going to make it a little bit tough. So the way that I wrote this out for letter A, I wrote 2 times 22 plus 3 times 15, because they have 2 cases of asparagus and 3 cases of tomatoes. So 2 times 22, because 22 is how much asparagus costs per case. And then 3 times 15, because 15 is how much tomatoes cost per case.
Okay.
So I'm basically
to
plugging in
and make it less.
Yeah, for every letter.
Make it easier.
For every letter, I'm essentially plugging it in this same way, where the 22 and the 15 won't change, but the amount that I'm multiplying 22 and 15 by will. So
okay, so I think
that'll work out better than looking at it as 5 cases, because each case costs a different amount.
Okay, so yes. Okay, so restaurant A asparagus 2 times how much it was? 22 for asparagus, $22, and $15 for tomatoes. Okay, so asparagus restaurant A is 2. That would be asparagus. God, why do they gotta get so crazy on me?
You could do it. You doing okay? You need help?
No, I just need to let my brain do it.
Gotcha.
Okay, restaurant A. So $22 times 2. 22 times 22. Okay, so we have 44 plus. And then restaurant A asparagus. I mean tomatoes. 3. 3 times 15 is 45. So the total for them would be, right? Is it fine if I add each one separately at the end, get the total for each one?
So that's what you need to do. You need to get
And
the
then
total
I'll
for
see.
each one, A, B, C, and D, and then we'll see which one is the highest.
Okay,
Cost the
45,
most.
40, that's 9, and that's 89. Okay, so 89. And then restaurant B, asparagus, restaurant B is 4. So 4 times 22 is 88, I think.
That's right.
Okay, and so then tomatoes is 1. So 15.
Good.
And then restaurant C is asparagus 0. And tomatoes is 3. So
Did you get your total for B?
45. Sorry, 88 plus 15 is 8 is 13, 13, 14. Shit. Sorry. 8 plus 5 is 13. 8 plus 1 is 9, 10, 103.
Good. That's right.
Okay, and then 45 for restaurant C.
Good.
And then restaurant D, asparagus is 22. And then tomatoes is 4. So 4 times 15 is 4 times that's 5 times is 20. 4 times 1 is 4, 5, 6, 60.
So what's your total?
And so 60, that's 72. Sorry, 82.
82 is right. Good job.
And restaurant E.
We actually, the question just asks, our options are A, B, C, or D. So our question asks which of the following spent the most on asparagus and tomatoes combined. So now we know how much A, B, C, and D spent on asparagus and tomatoes combined. So
Restaurant B.
Good. Very good.
Which is B.
That is correct. Great job.
That was a brain twister.
Yeah, I know there was a lot of steps to that one. But you
Great
got through
job.
it. You did
takes years to map. Howdy, Audit. Thank you, James. We're going to get back to your thing. Hi, Audit LA.
Hello. Howdy, y'all.
Okay, so here we go. Let's continue. Let's not get distracted.
Sounds good.
Number 4.
You want to read it?
Yeah. At a certain store, loose leaf papers comes only in packages of 400 sheets. If a student buys enough paper at this store to fill 3 binders with 150 sheets of paper each, how many sheets will be left over? Okay, I'll just do some math here. At a certain store, loose leaf paper comes only in packages of 400 sheets. Okay, 400 sheets. If a student buys enough paper at the store to fill 3 binders with 150 sheets of paper each, how many sheets will be left over? Only in packaging. Okay. If a student buys enough paper at the store to fill 3 binders with 3 binders. So 150 times 3
Mm-hmm.
first. Is 450.
Very good.
And so 450. If a student buys enough paper at the store to fill 3 binders with 150 sheets of paper each, how many sheets will be left over? 50. Number B. Letter B.
So not
Am I
quite.
wrong?
Yeah.
Because I
So
did a half thing,
this
a
is why.
half solving.
If the loose leaf paper only comes in packages of 400 sheets, then if we buy 400 sheets, then we're actually going to be short 50. So the question is asking if we buy enough paper to fill 3 binders with 150 sheets of paper each. That means if we buy enough paper, meaning we're buying at least 450, that means we need to buy more than one package of 400. So if we buy 2 packages of 400, then what is 400 plus 400?
800.
800. So that means that that's how much we're going to need to buy. So if we buy 800,
Dang.
if we buy 800 and
It will
then we
be,
fill
yeah,
those
then it,
we fill those 3 binders and fill those 450, then how many are going to be left over?
350.
350. Very good. Which is
Number,
going to
letter
be
C.
letter C. Very good.
That's true. They try to sneak me on that. They knew I
Yeah.
would just go right to. They just told me about this.
That's
Notice
great.
that choice 350 is a partial solution, but is not the answer to the question.
No, yeah,
Okay.
that's how they'll get you. They love to throw the partial solution in there as a potential answer, but we've got it.
Okay. 3 friends are baking cupcakes for a bake sale. Each batch of 24 cakes requires 2 cups of flour. The friends have a single 5-pound bag of flour that contains 19 cups of flour. How many whole batches of cupcakes can they bake? How many whole batches of cupcakes can they bake? Okay. Let's flip the page. Each batch of 24 cupcakes requires 2 cups of flour. 24 times 2. 4 times 2 is 8. 2 times 2 is 4. So 48 cups of flour. Let's see if I even need it to be that much.
Do you wanna tell me what you're doing?
First, I want to try to figure it out. The
Okay.
friends have a single 5-pound bag of flour that contains 19 cups of flour. 5-pound bag of flour that contains 19 cups of flour. Okay. How many whole batches of cupcakes can you bake? Okay, so first I did each batch. I first did uh,
What you thinking?
I don't think I'm understanding the problem.
They do give us some information in the problem that we don't need. So I can read through the question again and just focus on the information that we need the most. 3 friends are baking cupcakes for a bake sale.
Each batch of 24 cupcakes requires 2 cups of flour. The friends have a single 5-pound bag of flour that contains 19 cups of flour. How many whole batches can they bake? How many whole batches of cupcakes can they bake?
How much is a whole? 5? No. How much is
a whole batch requires 2 cups of flour. So what we need to find out is with a bag that contains 19 cups of flour, how many entire batches that take 2 cups of flour can they make? So we need to figure out how many times does 2 go evenly into 9? Or excuse me, into 19. How many times does 2 go evenly
8.
into 19?
8.
You're close.
No.
9. Because what's 9 times 2?
Oh, but remainder 1. Okay, yeah. 9.
Yeah, so 9 times 2 is
18.
18, exactly. So they have enough to make 9 whole batches, and then they'll have some left over. So because 19 divided by 2, excuse me.
So the single 5-pound bag is not needed information. It's just a pound. I mean, they're just saying the bag they have contains 19 cups of flour.
Yeah, that's the important information is the 19 cups of flour. The 5 pounds is not in this case. 19 divided by 2 equals 9.
How many batches of cupcakes can
1.
they bake? So 3 pounds of baking cupcakes each batch. Okay.
How are you feeling?
So I guess they're not able to make 24 cupcakes, and so we have to reduce it.
No. So that the 24 is another number that we don't really need to worry about because a batch takes 2 cups of flour and a batch contains 24 cupcakes. So they can make 9 batches, which would be 9 batches of 24 cupcakes. And that would be relevant if they were asking us how many cupcakes in total can be made. But they're not asking about how many cupcakes can be made. They're asking how many batches. So the fact that each batch has 24 cupcakes isn't information that we need in order to solve the problem. Does that make sense?
So how many cupcakes can they make, or how many whole batches of cupcakes can they bake?
9. Because we determined that 2 can evenly go into 19 9 times. So that's how many batches they can make.
Oh, but it won't. Oh, okay, but there will be extra.
There will be extra, but since it's asking how many whole batches of cupcakes can they bake?
Bag of flour that contains 19 cups of flour. Yeah, and so 2 divided by 19.
19
right?
divided by 2, or 2 into 19.
Yeah.
I know those words are tricky.
Okay. I think I guess I just have to really know what the question is and what I'm trying to answer. Because I think I got so confused with the 24 cupcakes and the 5-pound bag and whether they're asking for cupcakes or how much batches.
Yeah, this is something that they definitely will do on these kinds of tests is throw information at you that you don't need to solve the problem. So yeah, for this one, the most important pieces of information are how many cups of flour are required for each batch of cupcakes, and then how many cups of flour do the 3 friends have. So since they have 19 cups of flour, each batch requires 2 cups, they can make 9 whole batches.
Yeah. Okay. We're going to the next one.
On to the next one.
Number 6, a certain health insurance plan costs $3,000 per year for a family of 6. If each member of the family has $750 in medical expenses in a year, and the plan pays 100% of those expenses, how much will the family save by purchasing the plan? So a certain health percentage, a certain health insurance plan costs $3,000 per year, right?
Mm-hmm.
3,000 for a family of 6. If each member of the family, which is 6, has 750 in medical expenses in a year, and the plan pays 100% of those expenses, how much will the family save by purchasing the plan? Okay, if 750 in expenses a year, so 3,000, I would say first. I think I would divide 6 into 3,000 by 3,000.
Not quite. So the health insurance plan costs $3,000 for the entire family. But actually, you know what?
Which is 6.
You could solve it this way. Now that I'm thinking about it, you could solve it that way. That wasn't where my brain went first. But if you want to just calculate, I guess you can calculate it that way. Do you want to try it that way, or do you want me to show it to you the way that I'm thinking?
Well, then also I can just do,
What?
or I could do 750 times 6.
Yeah, that's what I was going to recommend.
Okay, okay, let me just do that. Oh, wait. When I'm multiplying,
Yeah.
do I need to cross out the 0? Or just do 6 times 0, right? I don't need to do any
6 times
subtraction.
0. 6 times 0.
Is 0.
You're
6
only,
times,
because 6 is only a 1-digit number, you're not going to need to worry about that whole 0 placeholder thing that we looked at the other day
yeah.
when we were talking about like multi-digit multiplication. But
Wait.
yeah, I'm solving out the multiplication problem
6
on my paper too,
times
if you want to look.
36 is 138. No, I don't want to look, and I can't. When you're talking, I can't think and do the problem. Just so you know.
Sorry,
But I
I'll
don't
let you
want to
work.
look at. Yeah, I don't want to look at yours either. I want to do the work on my brain will not learn.
Sounds good. Go for it.
6 times 0 is 0. 6 times 5 is 30. 5
6
times
times 5 is 30. That's right.
30. 6 times 7 is 36. is 39, 44, 42, 43, 44, 45. So 4,500. Some of those expenses. How much will they save by purchasing the plan? They'll save. They'll save 1,500.
Very good. Good job.
Yay. Woo!
You
So
got
I multiplied. I multiplied. I wonder. I think I would have gotten it anyways, even if I did 3,000 times 6.
If you did, you mean 3,000 divided by 6?
I mean, 3,000 divided by 6. And then.
I think you would have, but then you just would have had to multiply by 6 again at the end to figure out how much the family is saving.
Yeah, so this is actually better. It was faster. Okay, well, like, the thing is that I got it.
Very nice. Do you need to see my paper at all for that problem to show your work?
Yeah, no, that's right.
Okay, nice. I think I did just get a text from my roommate, so I'm going to take my paper off the screen for a sec.
Okay. Oh, because you're looking. Yeah, yeah. Cool.
For a sec. Oh, wait. 1 sec.
Oh wait, oh wait, oh wait, wait, oh wait, oh wait. Whoop! I put my my icy in the freezer a little too long, and it keeps wanting to explode while it's frozen, and it's like feels like it's going to be like a bomb.
Oh no.
I just want to drink it. I think I'm just going to wrap it in paper towel while I open it. But it's a fuzzy drink. So it's just going to keep fuzzing while it's frozen.
Those ice drinks are good.
I love them. Do you ever feel like you keep getting thirsty though? Like, or is it that you're finally like rehydrating?
Yeah, when I'm
Like
drinking
it's
things that
literally
aren't water, I do
exploding.
sometimes feel that, or I just feel like I keep staying thirsty.
Be proud of myself. I'm not proud of myself at the moment. I feel like my brain is having a hard time like being good at this stuff, you know? Though I did just start. I guess I can say that in a little bit.
All right. I texted my... Sorry. You wanna bring the paper back up?
Yes. Am I allowed?
Yeah. All right. I can only have my mic on one at a time, or else it just sounds crazy.
Yeah.
I texted my roommate back. It's possible that he'll need me to hop off and help with something fairly soon. But I'm not sure. I might be okay. I'll just let you know if something comes
Okay.
up. We did just finish a page though. Do you want to go ahead and flip to our next one so that we can get started with lesson 5?
Yes.
All right, let's do it.
Lesson 5 is distance and cost.
Distance and cost. That's right. So if we want to go ahead and get right into it. Lesson 5, distance and cost. Distance. On the mathematical reasoning test, you'll see questions that will require you to apply formulas. When a relationship is constant, use a formula to set up the information about how the different parts relate to each other. One of the most commonly tested formulas deals with distance, rate, and time. Distance is a product of the rate at which something travels and the amount of travel time. So that's written out here in a formula as distance equals rate times time, or D equals RT. We always remembered that as dirt when I was in school. Distance equals rate times time. If you can remember dirt, then you can remember DRT. That's that relationship between distance, rate or speed, and time.
Is that how they're gonna have you multiply or do something?
Yeah, so just in the same way that we were using is over of equals percent over 100 when we were working with proportions and percents, this is going to be a formula that we'll use if they give us 2 out of those 3 values, and it'll make sense once we look at example problems. But if they give us 2 out of those 3 values between distance, rate, and time, then we will have the formula that we need to solve for the missing value. So, for example, if they say that, let me see.
Hi, Hero.
Hey, Hero like coding. If they say that a car is going 60 miles an hour and they drive for 1 hour, then how far did the car go? Well, if we're thinking in terms of distance equals rate times time, the rate would be 60 miles per hour.
What if we didn't know how fast the speed was? And do they try to make us figure it out just based off of the time and the distance?
Well, yeah.
So the average speed?
when there's 3 values that we need to solve for, if we have at least 2 of those values, then we can, excuse me, if there's 3 values that we need for this formula, which there are, if they give us 2 of those values, then we're going to be able to solve for the third one. So if they say a car was traveling at 60 miles per hour for 1 hour, then the rate is 60 miles per hour times the time, which is 1 hour, and
So 10
then
miles per hour.
60 miles per hour.
I mean, 60 miles per hour. I was like 60 times, I was like 6 times 6 times 10.
No, but not 10 hours, just 1 hour.
Well, I was thinking 1 hour, 60 minutes is 1 hour. Right? It says 1 hour.
That's true, but that's not related to this.
Wait, go. Read it again? Sorry. What's the question again?
I'm just coming up with an example, and I'm trying to use an easy number because 60 miles per hour, that means that in an hour, a car travels 60 miles. You understand?
Right. So I was saying an hour is 60 minutes.
Oh, sorry. I thought you said a minute is 60 seconds. I'm sorry. Which is also true, but yeah, never mind. You're right. You got it.
I was trying to do quick division, and I was saying 60.
So what is the
60
distance?
60 miles in 1 hour. 60.
Yeah. So the distance would be 60
miles an hour, and 1 hour would be 60 miles an hour.
Yeah. So what if a vehicle was going 120 miles per hour? Then how far would they go in 3 hours?
20 miles. If they were going
120 miles per hour and they traveled for 3 hours.
How far would they go?
Yeah.
360 miles.
Good. Yeah. So you already understand kind of a foundation of how this formula is going to come into play. As we continue to read through here, we're going to see some examples. I was just trying to come up with a simple one. It's fairly simple.
Oh, I see. Distance, rate, time.
Yeah.
Ooh, that would be a cool dirt, like D, how you said that you guys were like dirt. If you were a motorcycle rider and you were a math nerd and you could put dirt on your shirt. Like D equals RT, dirt. Distance, rate, time. That's right. Okay, that's enough. So
I kind of already went through an example, but do you want to go ahead and read through the examples that they've got here now? Nice.
Yeah, because I like visually reading the letters.
Very nice. So notice that letters or variables can be used to represent the different parts of a formula. A formula allows you to substitute known values for certain variables and solve for the unknown variable. Example 1. How many miles can you travel if you drive at an average speed of 55 miles per hour for 3 hours? Step 1.
How many miles can you travel if you drive at an average speed of 55 miles per hour for 3 hours? So just really quick, 3 times 55.
That's right. So it lays that out right here with step 1. You know the rate, 55 miles per hour, and the time, 3 hours. Substitute the values in the distance formula. So we have distance equals 55 times 3. Multiply to find the distance. 55 times 3 equals
165.
Good. Very nice. So does this make sense so far?
Yeah.
All right. So there's a handful of formulas that are listed up here. So dirt, or distance equals rate times time, is the first one that's laid out, which relates to those 3 concepts of distance, rate, and time. Now we can look ahead from distance to cost. Another helpful formula is the cost formula. It expresses the relationship between cost, the number of units, and rate, price per unit. Note, the word per means for every 1 unit. The cost formula can be written as follows. Total cost equals number of units times price per unit, or C equals NR.
C equals NR?
Yeah.
Cost per number of units. Okay.
That makes sense?
Yeah.
Sounds good. So let's go ahead and look at example 2. Example
Excuse
2. Yes.
Sorry, that's all.
Bless you.
Thank you. I was saying excuse me beforehand.
You're good.
Pardon my manners, Mr. Harkey. I have to sneeze.
Yeah, put your manners in.
Oh, God. Okay.
Example 2. At a bakery, a package of frosted cookies is priced at $3 per package. If a teacher treats her class by buying 4 packages, how much would the cookies cost before tax?
So 3 times 4.
Very good. It says you know the number of units, which is 4 packages, and the price per unit, which is $3 per package. Substitute the values in the cost formula. Total cost equals 4 times $3. Multiply to find the total cost. 4 times $3 equals $12. Well done. You did that right away.
Yeah. If you know any 2 of the 3 variables in a formula, you can solve for the 3rd variable.
And that's what I was saying. What it says right here, if you know any 2 of the 3 variables in a formula, you can solve for the 3rd variable. That was the same thing with distance equals rate times time. If they give you distance and time, then you can figure out the rate or the speed. If they give you distance and rate, then you can figure out how much time passed. And if they give you distance and time, then you can wait. What did I not say yet? Oh, yes. If they give you rate and time, you can figure out the distance.
Yeah.
I forgot which combination.
I keep thinking of that Cake song. She's going the distance.
Oh yeah.
She's going for speed. She's all alone in a time of need, getting her GED.
Woo! I love the way that song starts without any music, and then the music just comes in, reluctantly crouched at the starting line.
Engines pumping and pumping in time. The green light flashes, the flags go up, yearning and burning. I love that. Oh shit, mother effer. I keep forgetting that it's Frozen. And I'm thirsty. Fuck.
Good job censoring your curse words in school.
Oh, my bad.
No, I'm saying good job.
Oh,
you didn't say the actual word.
I thought I swore. Okay, good. I think my brain earlier today we did public works call.
Oh, I missed that. How was that?
It was good. There was like 5 of us who called in.
Okay. Very cool.
And so I feel like there were some there was like somebody being like awarded, for being in the city doing their job, and they had their family there. So we were all making sure we were like, oh, we see there's kids there. Or me personally, I'm always like, okay, I really will not try to swear or anything, and just be very clear about my message. Anyway,
nice.
Moving along. Sorry for the explosion of juice. Juice. Oh, actually, you know what? I have a huge thing of water. Can I just grab it really quick?
Yeah, go for it. And hello to y'all.
Unless I should grab an ice cold beer. It's Friday. It's not
You're an adult.
3 o'clock yet. You can only have beer on Friday after 3.
You can only have beer on Friday after 3?
Yeah.
Look at you being all disciplined. I love that you're just drinking straight out of the jug.
I was like, I'm not wasting 1 more minute getting a cup or anything. We have to keep going. Because what did you
that was the same. I think I was telling you this the other day, that when I played water polo in high school, the goalies would have to hold those kinds of jugs above their head while they're treading water with just their feet. Like, oh yeah, really hard.
Yeah, I'm sure those underarms get really like everything.
Your legs, your core,
the thighs, everything. Man, even that was hard. Better get in that pool. Who's gonna join me for pool aerobics?
Next time I'm over at your place. Let's do it.
Oh my God, yes. Jacob has a Speedo, guys, and we might do aerobics in his Speedos. We'll both have like matching like thong Speedos. It'll be great.
Maybe.
Anyways, we'll keep that off the kid learning line here. Look at your
maybe muscle. For the best.
Okay. Okay, so here we go.
Gosh, example 3.
Yes, example 3. Wow, my brain was all into it and then I got distracted. Okay. Example 3. Max bought oh, can I read it?
Yeah, go for it.
Okay. Max bought a set of 4 floor mats. Oh, they did this on purpose. 4 floor mats for $44.
That actually is funny.
It is funny. How much was the price per floor mat? 4 floor mats for $44. All right, 4 times 44. And so how much was the price per floor mat? Per means each one.
You did 4 times 44?
Per means, it says Max bought a set of 4 floor mats for $44.
Uh-huh.
4 floor mats for $4.
Meaning that the set cost $44.
Right. So how much?
You don't want to multiply.
How much was each floor? Oh my God, my pen literally just ran out. How much was? Oh, there we go. How much was each floor mat in the set?
Yes.
That costs $44. So 4 divided by 40. No, am I saying it wrong? 4.
It would be 44
divided by 4.
Yeah.
Jinx.
Which you could also say how many times does 4 go into 44?
Oh, I would do 4 times. Oh.
Because if with this one, if we are plugging this into that C equals NR formula, that's total cost equals number of units times price per unit. So,
okay, so
what
176.
What?
176.
No.
Sorry.
So C equals NR. Because we're not solving for C, we're solving for R.
Oh, whoops! Sorry.
What they give us here, where you see where it says R.
I'm dividing. Sorry, I keep interrupting because I feel like when you say wrong or whatever, I feel like I like when you say you're multiplying when you should be dividing. Then my brain goes, oh, it just clicks it faster. Otherwise I'm trying to hear a whole other thing instead of realizing what I did wrong.
Gotcha. Okay.
Tell me what I did wrong first.
You just plugged in the wrong part of the formula. But so that was
I did multiplication though, right?
Yeah.
And I'm supposed to divide for how many 4s go into 44 because they're asking individually each mat in the set how much.
That's right. I just wanted to make sure that you understood where things fit into the formula and why. So that's how you'll know in the future when you see future problems, like which operation you need to do.
Okay, so sorry, I'll listen now. Say it again.
Okay, so the
now
formula
that I know I need to listen.
So the formula that we're looking at here is C equals NR, and those variables stand for the C and N and R. The C means the total cost. The N is the number of units, and the R is the price per unit. Now, there's a few ways that we can solve for the value that we need here. We can just use that formula as it's written, or we can just reinterpret C equals NR as R equals C over N, because both of those formulas are essentially dealing with the same values and expressing the same relationship between those values. But so if we know already that we're solving for R and for the cost per unit, then we can just plug in the values that we have as R equals C over N, which is how we get 44. We know that's our total cost, so that'll go in as C. And then the number of units is 4. There's 4 floor mats. So 44 divided by 4 equals 11.
Mm-hmm.
Did that make sense?
Yeah.
Okay. Are you sure?
Yeah, I was just wondering. The NR, what is NR again?
So N is the number of units, which in this case is 4. And then the R is the cost per unit, which is what we were solving for in this problem.
No, I mean when it says C equals NR.
Yeah.
What does NR stand for?
So NR means N times R. N is number of units, and R is cost per unit.
Oh, okay. N is
number of units.
Units. Okay. So it doesn't stand for anything. Okay. And R is
Cost per unit or price per unit.
price per unit. So C cost equals number of units and price per unit.
Yeah, number of units times price per unit. Exactly.
Okay.
How'd you feel about that one?
I felt good about it until we started breaking it all down.
Well, you got example 2 pretty much by yourself. I didn't even really help you with that one.
Yeah.
I think that maybe that one was easier because the values just plugged in directly the way the formula was originally taught with C equals N times R. So it might have looked like all of them were going to be multiplication the same way. But yeah, as we do more of them and we get used to plugging in values for different variables and different parts of formulas, I think it'll come to make some more sense.
Okay. Total. Oh, here we go.
You want to jump into the practice?
Yeah. Total cost equals number of units times price per unit, or CNR. There. That's where.
Oh, you're looking at the formula again. Nice.
I was just writing little notes on my book.
Nice. I do think one thing that it would be good for us to just take a look at before we look at the practice on the next page is this section right here on page 232, where in the top left of the page, it shows key ideas, and it shows different ways that these formulas can be expressed, where it just might make sense to use some of these over others, depending on what we're solving for in any given problem. So the following ideas all indicate multiplication. N times R, NR, N parentheses R, or N, that's also N times R right there. So all of these are just different ways of expressing that we are going to be multiplying. Does that make sense?
Okay. Yeah.
And then same thing here. The following indicate division. C divided by N or C over N. Both of those mean that we're dividing.
And this is specifically when it's talking really about distance and cost.
All distance or cost. All of the problems that we just looked at have to do with either distance or cost.
Okay.
Now, that's true though. What these symbols mean, like the X for times, that dot for times, just putting a variable next to a number, that means multiplication. And then when the parentheses are used like that, with the numbers right next to each other, that would mean multiplication too. So what we're looking at here is specifically relating to distance and cost, but these symbols stand for multiplication and these symbols mean division in any context.
Okay. Okay.
And then a formula can be...
sorry.
Do you want to look at the next part where it says...
I don't know. Go ahead. I want to hear you.
You're good. A formula can be rewritten to solve for each of its variables. So with each of the formulas that we just looked at, if we rewrite the formula to isolate a different variable and get a different variable by itself on one side, then that can just give us another way that we can plug values in to solve for whatever a missing value is. So C equals NR can also be used in a problem as C over N equals R, or C over R equals N. And then the same thing with the DIRT, or distance equals rate times time formula. We can write that as D equals RT, or if we're solving for time, then we could write D over R equals T. Or if we're solving for rate, then we could do D over T, distance over time, equals rate. So we're really just looking at two formulas there, C equals NR and D equals RT. But the book is just showing us the different ways that we can express each of those formulas, which might be useful depending on what it is that we're solving for. Okay, how does that feel?
Good. And I also wrote little arrows
nice
to remind me like what this is talking about. These are all the ways that you can write it too.
Very good. Good job.
Oh my goodness. So this is how they get you to learn about all the letters and all that. So
Oh
is
yeah.
this considered, some of this like considered algebra or no? We haven't
Yeah,
gone there.
anytime that we are using letters in math, yeah, that would be algebra.
So we're learning algebra right now?
Mm-hmm. Look at you.
Wow.
You're working your way up in the world.
Oh my gosh. That's
Oh,
so
that's
cool.
awesome.
Have the other math stuff we were doing, was that also algebra?
Sometimes when I would write an X in there, I mean, there's a lot of math that kind of falls under the umbrella of algebra,
Like
but like
power to
even
the 2, is that all algebra or no?
not explicitly, not
Okay, okay.
but like when we were working with proportions and percentages and I was using the X to represent 100, like using the X to represent a percentage or the is or the of or whatever the missing value is, anytime you're
Mhm.
doing that and plugging in X as a missing value that you're solving for, or plugging in any letter as a missing value that you're solving for, that is algebra. That's an algebraic expression once there's a letter in there.
Algebraic. Okay, cool.
Algebraic, yep, that's the adjective form.
Good to know. Okay, so do we still have a little bit of more time to do practice 5?
Yeah, we've been going for an hour and a half. You wanna work on this page 233?
Yeah.
Sounds good. Let's do it. So I will move my book over so we can see it a little bit. And looking at practice 5. A. Each problem below includes 2 of the 3 variables from either the distance formula or the cost formula. Write the missing variable you need to solve for. Then decide which of the following formula variations you would use in each situation. The first one is done for you. Okay, so number 1, and they're not even giving us values here. They're just having us indicate what we're solving for and then what formula we would use to solve for that. So number 1, they do for us. So if we are given distance and time, that means that the missing value that we don't have that we need to solve for is going to be what?
Wait, what?
They give it to us. Number 1. Are you looking at number 1?
Yeah.
Okay, so if we are given distance and time, that means they've given us 2 of the variables and we just need to solve for the missing third one. So what is that? What are we solving for?
Distance and time equals speed.
No, yeah,
Oh,
or rate. You can also say
rate.
rate as speed. They tend to say
Okay.
rate in here, but the rate, speed, same thing. So
The,
we're
like
solving
when
for
the
rate.
officer pulls you over and they say, "Do you know what rate you were going at?" Okay.
That's a good point. So what formula is listed there as the formula that we would use to solve for rate?
R,
And tell
right?
what's the whole formula?
Oh, D, distance time equals rate.
So if you say distance time, that makes it sound like you're multiplying distance times time.
Oh. Distance.
Are you looking at number 1 where it says formula?
Yeah, but so DT.
D over T or D divided by T is what it
What's
says there.
T?
Time.
Times or time?
Time. So rate equals
Yeah.
distance divided by time. You said
So
distance
what
time.
did I?
That sounds like multiplication. Because remember, if they're
Oh,
just listed
no.
next to each other, like if we just have dt, that means distance times time. If we have d over t, that means distance divided by time.
Okay. Yeah, I definitely was thinking distance and time equals rate.
But it makes a difference if you multiply or divide because you're going to get the wrong
No, I
answer.
wasn't thinking times,
Okay.
right? It's
That's good.
time is the amount of time, like the amount of time, right? The actual clock time.
Right. So can you tell me the formula that we would use to solve for rate?
Distance and time.
I'm asking for the formula. So what do we do? That yes, we have distance and time. What do we do with them?
Oh, you. You multiply the distance and the time.
No. You divide distance divided by
Sorry,
time.
divide distance divided by time equals
Yeah.
rate.
Good. Very good.
Distance divided by time.
So that first one
Right.
they did for
'Cause we're
us. Now the rest of them, they give us two of the variables, and then we're just writing down what's the missing variable we need to solve for, and what formula are we going to use to do that. Before we do that, I just
Okay.
want to make sure you see that up here, we see 6 formulas. Now, really, it's just 2 formulas where each formula is expressed in 3 ways, so that there's one version of dirt with D by itself, there's one version of dirt with T by itself, and there's one version of dirt with R by itself. So that way, if we're solving for distance, we use the first one. If we're solving for time, we use the second one. And if we're solving for rate, we use the third one. Does that make sense so far?
Yeah. First one is time.
First one is if we're solving for
It's
distance.
distance.
Second one would be if we're solving for time. And then third one would be if we're solving for rate.
Okay.
All right. So you want to look at number 2? Or are you making a note real quick?
Yeah, I was putting distance,
Yeah, go ahead.
time, rate, but distance equals rate and time.
Rate times time. Yeah.
Rate times time. Annoying. Okay.
You okay?
Okay. This is brain scrabbly. This is very new to me for sure. I've never, ever seen writing like this in my life. I've only seen division or fractions, and that was always scary.
That's okay. We're taking it as it comes. If we need to slow it down and go over more examples, we can always do that. But looking at number 2. Number 2, what are we given?
Rate and time.
Great. So what would we be solving for?
Distance.
Distance, exactly. So we'll write that in.
Distance.
So which formula would we use?
Rate and time. You would divide what?
Which formula that we see up here? D equals RT, D over R equals T, or D over T equals R?
Oh, you mean like how would I write it out?
Yeah, so each of these is a formula. That's what they're asking us for. They're asking us to write in formula. Which formula are we going to write?
For distance. Oh, given. So rate and time. We need distance. And, right? Am I right? Distance and something else? Or are you saying we already
You've just got to choose one of these 3 up here. So if we're solving for distance, which one do we choose? The first one, the second one, or the third one?
First one.
Good. So you'll just write D equals RT.
D equals RT. The formula for distance is D equals RT.
Good. Very good. So next one, what are we given for number 3?
Distance and rate.
So what's the missing variable that we'd be solving for?
Time.
Time, good. And which one of our formulas up here is the formula for time?
D over R.
Good. Very good.
dr equals time.
D over R equals T. Very good.
Yeah.
Is it making a little bit more sense now?
Kind of.
Nice.
Cost and number of units. Okay, hold on.
Yeah, so if we're given cost and number of units, then what would we be solving for as the missing variable?
Cost and number of units. Cost. We would cost and number of units.
So if we're given cost and number of units, then looking back at the section on the last page about cost, what is the missing variable? When we have C equals NR, where C is total cost, N is the number of units, and R is the price per unit, which one of those variables is the one that we do not have that we're solving for in number 4?
C
So C is the total
equals
cost.
NR.
We do have that.
Yeah, so C equals NR.
C equals NR, that's one version of the formula that we have here. C equals total cost, and we do have that. So what is it that we don't have other than total cost? There's 3 variables. There's total cost, number of units, and price per unit. So we have the total cost, and we have the number of units. So what do we not have?
The price per unit.
Price per unit, good. So solve for, we can put in price per unit. And I'm going to put in parentheses R, because that's R is price per unit in the formula C equals NR. Now, if we are solving for price per unit, that means that we're going to want to use the version of this formula where R is by itself on one side of the equation. So which version of this formula are we going to want to plug in?
Cost and number, we have C over N equals R.
Good. C over N equals R.
Cost and number of units equals this. And R means price per unit.
Good. R means price per unit. That's
So
right.
we have the cost, and then we have the number of units, and then the R would be equals the price per unit.
R equals price per unit. That's right.
Okay. Okay, number of units and price per unit would be solving for the rate.
So rate isn't going to be one of the.
Oh wait, price per unit, number of units. Solve for amount.
Amount
Cost,
of.
number of units and price per unit. Cost and number of units equals R. Okay, so number of units and price per unit. Help me.
Yeah.
Why
So
am I not
look,
getting this?
no, you're okay. So with C equals NR, C is total cost, N is number of units, and R is price per unit. So what we have here, we have the number of units, which is N, and we have the price per unit, which is R. So which letter do we not have?
The cost per unit?
Yeah, not cost per unit. We have cost per unit. What we don't have
the
is the
total cost.
total cost. Very good.
Okay, that's I was getting confused with cost per unit. I was like, I don't know. I think that's the same thing as price per.
Yeah. So
Okay, so total cost and then the number of units and the price per unit.
So if we're solving for total cost, then which version of the formula are we going to want to use here?
Number of for total cost, solving for cost.
Solving for total cost, which version of this formula are we going to want to plug in?
The C over N equals R.
So we would want that if we're solving for R, because R is the one that's by itself.
Oh, wait,
on one side of the equation. What?
Total cost and rate per unit? No.
R is price per unit. Here we're solving for total cost, which means that we're solving for C, which means we want the version where C is by itself on one side of the equation. Which version of the formula is that?
C equals NR.
Good. C equals NR. You feeling okay?
Number of units and price per unit. C equals. What's C equal again?
C is total cost.
Oh, total cost. Number of units and price per unit. Okay. So, number of units and price per unit solving for the total cost. Is that right?
Yeah. Mm-hmm.
Okay.
And then did you
And
did you write down the formula?
y- uh, for total cost would be C equals NR.
Good. That's right.
And so total cost, the number of units and price per unit equals the total cost. And that is that. C equals the number of units and the price per unit. Okay.
Number of units times price per unit. That's right. Ready for number 6?
Yes. Yes.
All
No,
right.
wait. The formula. So then it's solved for C equals NR.
You're still on number 5?
Yeah, then
Yeah.
what's the formula?
What's the formula?
What's the difference between solve for and the formula?
So the formula is what we use in order to solve for total cost. So if we're solving for the total cost, then we're going to want to use the formula C equals NR because we have N and we have R, so we'll multiply them together. Looking back at number 4, we're given cost and number of units, which means that we're solving for the variable we don't have, which is R, price per unit. Because
What
of
did
that,
you put?
what did you say?
What did you put? Oh,
Do you need me
total
to-
cost. So you just
Yeah.
I put C. That's why.
I mean, you could do that. I would
And the
recommend.
formula is C equals NR.
Yeah. So yeah, where it says
But
solve
C
for, I would write out not just the letter, but the
cost.
longer form value of what it is that you're solving for. So yeah, for number 5, you're solving for total cost.
Yeah, total cost, which equals C.
Total cost, which equals C. That's right.
I just need to remember that. Okay, and then the formula is written C equals NR.
Correct. Very good.
Okay, I can get rid of this stomach ache.
Oh, you have a stomach ache?
No, it's just a stress stomach ache.
Oh, I'm sorry. If you want to finish up this next one and then just call it before we go on to part
No.
B. No,
No.
Oh,
No,
okay.
no.
Okay, if you say so. You want to
Okay,
look at number 6?
yes, given cost and price per unit. If I'm given the cost and the price, total cost, and the price per unit, I will need number of units.
Number of units. Good. So that's what we'll write in for what we're solving for.
So we're solving for equal n.
Yeah, I would probably just write in number of units and then in parentheses n so that you know what each of these letters stands for. Because if you're mixing up what the letters stand for and what the letters mean, then it might help you to write out the full name. So
Okay,
number
so
of
I'm
units.
writing so cost and price per unit solving for number of units.
That's right. So what formula are we going to use to solve for a number of units?
C equals NR. No.
Because
C,
with that
R.
was sorry, what'd you say?
Nothing.
Yeah. So with C equals NR, we'd use that if we're solving for total cost because the C is by itself on one side of the equation. So which equation has N on one side by itself?
The third one, C over R equals N.
Good. C over R equals N. Very good. Yeah, anytime once we know what we're solving
Number
for.
of units?
Yeah. Once we know what we're solving for, then we'll want to use the formula that has that variable by itself on one side of the equation. Now, the truth is you could still use C equals NR. You would just have an extra step where you'd have to divide at the end and it would end up you'd end up with the same answer. But I do think that just for this
C over
section, while they're not giving us the values and they're just asking us to identify what is it we're solving for and what formula are we going to use, I think it'll be good to write in the formula that they're looking for. How are you feeling?
I just feel like I'm always not going to feel that great when I'm doing this. So,
well, we'll keep working. We'll keep working through practice problems, and if you have more questions, you can always feel free to ask, and I can do my best to try and break things down and make it make sense. But with all of these problems, we just looked at a couple of formulas that have spaces for three variables. So the distance equals rate times time, and all of its various ways of being expressed. And then also C equals NR for total cost total cost equals number of units times price per unit, and all of the different ways that that one's expressed. Anytime we're dealing with a problem where we have 2 out of those 3 variables given to us, we can solve for the third one. And we're going to want to do that by using the formula that presents that variable by itself on one side of the equation. Chicago Jane, you got to go. Well, thank you for being here.
she said, see you on 9. Okay.
9, that's right.
Okay, maybe if we do some examples, I don't know.
Yeah. Well, let's do that. Okay, so part B, and I might even need to use another paper. Well, we might be able to make room. Okay. Number 7 says find. Do you want to read number 7?
Yeah, find the total cost of 4 flats of plants at $12 each. So 12 times 4.
12 times 4. Very good. So C equals NR, where N is 4, and the price per unit is 12. So if we wanted to be in the habit of, I don't know if I'm going to have room to write it out in as many steps as I would sort of like to. But yeah, C equals.
But so can I just write this out above each thing? I'm going to write out. So 4 flats would be the number of units, right?
4 flats is number of units. That's right.
Number of units. And $12 would be the price per unit.
Mm-hmm.
And which would equal 48, which would be the total cost.
That is correct. Very good.
And then how would I write that out? So I would write out
what I did, and we don't have a ton of room. I would have taken up more lines if there was more room on the page, but I wrote C equals NR, and then I put equals again, and I plugged in 4 and 12 for N and R. So I put C equals NR equals 4 times 12 equals $48. Does that make sense, or do you want me to write it out in more lines on?
It does. It almost makes sense, but not like as fast as you think it does.
Gotcha.
Equals 400 and what? How much does it equal?
$48, because 4 times 12 or 12 times 4 is 48. Is that what you're asking?
Yeah, I just don't know. What did you write before that? Equals 46?
So I put C equals NR, which equals 4 times 12, because 4 is N and 12 is R, equals $48.
Okay.
You got that?
Okay, let's try the next one. Find the total cost of 12 boxes of cookies if each box costs $3. Find the total cost of... Okay, so it already has the total cost.
Ooh,
oh, sorry.
They don't give us the total cost.
No, the total cost is what we need.
Yeah.
And we have the amount, the number of units is 12.
Good.
12 number of units, which is also known as NR. and they gave us the price per unit, which is $3 each.
Mm-hmm.
Okay. Okay, so then 12 times, I find the total cost of 12 boxes of cookies if each box costs $3. So 12 times 3.
And what's 12 times 3?
2 times 3 is 6. 3 times 1 is 3, so 36.
$36. Very good.
And so $36. 36 would be. So how do you write that out just in well, let me see how you did it.
So I did the same thing where I wrote C equals NR, which equals 12 times $3, which equals $36. Oh, whoops.
C equals whoa.
Sorry about that.
C equals NR.
Mm-hmm. It probably would be helpful if I did some of this on a different sheet of paper so that I could take up a little bit more space.
Okay, C equals NR,
Mm-hmm.
which equals 12 times, because dot is times.
That's right. Yeah.
Ooh, first time I got that right.
Nice.
Okay, 12 times $3. Right? Is that right? Equals
12 times
36,
$3. That's right. Yeah.
which the square total is $36.
Very good. You ready for number 9?
Hopefully.
I think I am going to use my notebook for this one.
Okay, yeah, I can see that.
Okay, so it's asking
Okay,
if 4
so-
tires cost $320, how much does a single tire cost? Is that right? Yeah.
Yeah, so 4 divided by 320.
Single tire cost. So
4, 8. I'm going to divide. I'm doing division.
yeah, so what are you dividing? Can you tell me which?
4 into 320.
Good. So because we're dividing the total cost, or C, divided by R, the price per unit, divided by N, the number of units, which is 4, and that'll give us the price per unit. Right.
Yes.
Nice.
I'm doing the math before I write all the letters.
Okay. That can work if you get the right answer.
4 goes in, so let me just do this. 4 goes into 320. Oh, sorry, 32. 4, 8. 16, so that's 8 times. I think 8 times 4. Yeah. Okay. Okay, so where are we at? If 4 tires cost $320, how much does a single tire cost? $80.
Very good. That is correct.
$80, and then I'm going to put in parentheses. If 4 tires, so I have the amount. No, I have the number of units and price per unit, and so I'm getting the cost equals NR. So cost, is that right? R.
So how did you write the formula? Or did you?
I'm writing it.
Oh, you're not writing the formula?
You're not listening to me, Jacob. You're now making me re-say what I just said.
I didn't hear you. Can you say it again, please? What?
$80 is the total cost.
$80 is the cost per unit. The total cost is $320.
Okay, so I messed up on that. So I have to do total price, then the price per unit. Price per unit is price per unit equals NR.
So price per unit is R. Is that what you got?
No.
N is number of units. Price per unit is R. So if we're solving for R in this problem, which is what we're solving for, we're solving for the price of a single unit, then we're going to plug in values to C over N equals R.
Mm-hmm.
You got that?
So
Let me know if you're doing okay. If you have a question.
I think I just need to like draw something out so I can remember all the.
No, yeah. So for something like this, if 4 tires cost $320, how much does a single tire cost? So we know we're looking at, I mean, that makes sense to buy 4 tires at a time because a car uses 4 tires. But if we've got 4 tires in the set and the total set costs $320, then to figure out how much each individual one costs, it's going to be 320 divided by 4.
Yeah.
Because if we divide this total into 4,
I'm not
that's
having a
the cost
problem
of each
with
tire.
that. I'm having a problem with remembering the letters and the numbers and what they are.
Well, that's why
So
I really
I'll just work on
recommend
that
you start by using the
later.
formula. I know that when we started this problem, you were saying, "Oh, I just divide it first before I think of the formula." That can work sometimes, but it can also make it really easy to make mistakes. So I think that even if you just have a cheat sheet in front of you, and like if you have, well, you can see the key ideas blurb on the far left side of page 232, where it shows the different ways of expressing the formulas, and then also at the top of page 233, where it shows the different expressions of all the formulas. So as soon as, I think this is why it's really good that they had us start in part A without even using the values, but just looking at, okay, if they give you distance and time, then you're solving for rate, which means that you'll use d over t equals r. If you're given rate and time, you'll solve for distance, which means you'll use the formula d equals rt.
I don't think the talking is helping. It's really making me frustrated, actually.
Okay.
So I'm going to take a break. No, it's not you. It's me. I need to be alone and draw out a little board like a child for myself. So I'm going to do that. I'm literally getting triggered right now.
I'm sorry, Laura.
No, it's not you. It's me. Okay. I'm allowed to feel this way. I'm allowed to feel this way.
Okay. Do you want to just chat? Just hang out for a sec? Just put away the work and take the paper off the screen and just stop for a sec? Let's do it.
Yeah. Let me.
One sec. I just realized that I think I might have been muted for a second there while I was trying to talk to you all. But please remember to give all of your love to Laura in the chat. I know that what she's doing by pursuing her GED after not having been to traditional school before, it's a lot. It's a very big endeavor. There's a lot of work that goes into it. We're going through the lessons that we're going through very quickly, much more quickly than students would traditionally be going through these types of lessons in a traditional schooling format. So please give her all of your love in the chat, because what she's doing is not easy. And we all commend her for the hard work that she's doing. I see Abnormally Normal 1219 says, Laura, you are doing great. Formulas can be tough. You hang in there, girl. You are kicking butt in the math world. Agreed. And thank you for the love, Abnormally Normal 1219. And if anybody else had any questions or wanted to review anything that we were working on related to distance, rate, and time, or cost, specifically with that formula looking at cost, number of units, and then price per unit, feel free to let me know in the chat. Let me see if I can see how many folks we've got in the chat right now. Right now, I am just viewing this on StreamYard, not looking at YouTube, but I can pull up YouTube on my phone now that I'm not using my paper anymore. See, Swancho Baby says, you will get there, Laura. Just breathe. Thank you, Swancho Baby. Yes, you will. We all believe in here, and we are all here to support her. Whoopsie daisy. Abnormally Normal says, most people call me Abby. Good to know, and nice to meet you, Abby. And I see we've got 14 folks that are in here. If you have not liked, make sure that you like the stream. I would imagine that most of the folks watching now probably are subscribed, but if you are not subscribed, please make sure that you subscribe to Laura FM. I'm sure that she would appreciate y'all's support as she's pursuing her GED, which, as I've said, is no easy task. So we commend Laura very much for taking on this undertaking. I'm also going to scroll up a little bit and see if there were any messages from earlier in the chat that I missed a little bit earlier on. But good to see you, Audit LA. Good to see a hero like Cody. I'm not sure. I'm not 100% sure if y'all are still in here. But I'm glad y'all made it in. Hello, Just Tiff 45. Hello, Chicago Jane 22. Hey, Laura.
Hi.
Oh, I don't hear you.
Uh-oh. You don't hear me?
Can I hear you now?
You don't hear me?
Uh-oh. I still can't. Oh, wait. I'm sorry. My volume was down. My volume was down. That was my fault. If you want to try again. I think it was me and not you.
Can you hear me?
Hey.
Can you hear me? No?
Now I can hear you. Now I can hear you. How are you feeling?
Okay. Just overwhelmed.
I understand. What you're doing is really hard. I really admire you for being vulnerable and working on this publicly.
It doesn't seem that hard.
It takes practice. And if you want...
It doesn't seem that hard, and I feel like I'm not, like, getting it.
No, you're okay. You just breathe. It's overwhelming because it is a lot of different letters that you're not used to. Like, you're probably not used to...
Why can't they just put C? Like, why do they have to make up all these fucking random letters that have nothing to do with what it's talking about? It's so hard for, like, it's not that hard. I'm just being a baby.
You're not being a baby. This is okay. You haven't been to school before. It's a lot. And we've already gone through so much. I mean, what is this number 8? Number 7? I can't even remember which. Yeah, this is part 8. I mean, I feel like we've already gone through like multiple units of like a typical school year's curriculum. And we're just going just each day and going through multiple lessons at a time. Like, this is a lot. Like, if it's a lot, if we just need to sit and breathe with this one, maybe give it some time, and then come back and look at some more practice problems. Like, you can get it. I believe in you. Well, we can take it one step at a time. And I might sometimes be just instinctively going through things faster than is really most conducive to making sure that we understand things. So when we do need to just take a break and look at things again, or even just take a break and put things away for a little bit and then come back to it a little bit later, that totally is okay. We can totally do that. And once we hop off stream, if you want to take some time to look at the online resources and see if there's more resources on there that can specifically help for practice with this type of stuff, we can totally do that. I think you muted
Yeah,
for
I
a
think
second.
I'm
I'm not
just
sure if you were
gonna,
trying to say that.
yeah, I'm gonna draw. I have a white erase board that I'm just gonna like draw for myself the letters and what it means, so that's easy in my head. So I guess I'm upset because it's gonna take me a little bit to like do that. And I wanted to be able to do a lot more.
Oh, I know it can be frustrating to when it's tough to grasp something, but you'll get there,
Like
and
if they're
you know
gonna
how you
keep
learn.
if they're gonna keep telling me if they're gonna make problems like this on the test or something, then I really need to know that. And I don't feel I feel stupid that I have to go back and look at total cost means, you know, at CNR. I'm still not getting it. So I'm just gonna draw it out, and then I just need to do it by myself for like 2 hours, and then I'll come back.
Okay, sounds good. And if you want, I'm not 100% sure. I might be hanging out with some friends a little bit later today. But if you want to text me later and if you want to just like FaceTime or something, and even like if you want to just chat about it, like not on stream or whatever you're comfortable with, however I can help you. You know, I want
Okay,
to
I'll
see you be
just
successful. I
maybe
want to help
uh I'll just draw it out, and then the next time we come on, I'll explain. I'll hopefully be able to explain very clearly what I learned, how I taught myself, or whatever.
you. Okay. And anytime if you want, like I said, to chat a little bit about what we're going to go over on a given day before we go live so that we already know going into it what to expect, what our goals are, what we want to work on, whatever you're most comfortable with. I
No,
mean,
I think we're doing fine. I'm just upset because this is hard for me.
well, I'm proud of you, and the chat is proud of you. And
Thanks.
Swancho Baby actually makes a good point in the chat. Swancho Baby says, Laura, you are learning what most of us take 12 years to learn. I mean, that is the truth, is that a GED is the equivalent of a high school diploma, which you graduate high school after 12th grade, after going through kindergarten plus 12 years of school. So, in order to pass a GED test, that means you've got to demonstrate that you've learned what a traditional student does learn in their 12 years of schooling after kindergarten. So, I mean, it's a lot. There is a lot to cover, but you've already made a lot of progress just up to leading up to day 8. And already we've made it through a chunk of the lessons that are going to ultimately comprise all of the math instruction that's in the GED test prep book. So we'll get there. There's no rush. It's not like we're on a timeline that we need to get through all of our lessons and pass all of the tests by. So
Okay.
we'll take it one
Well, I'm
step at a
just gonna allow myself to cry and then draw it all out, and I'll be fine. It's just something I have to go through.
That's
Uh,
cool. That's
it's
totally
it's
valid.
not about it's not about the math problem or what I have to learn. It's that I get triggered about my childhood and about my parents and about the teacher, like just everything. And so I feel like it goes back to thinking like I probably can. There's a chance I probably won't learn it. It's so pisses me off, and so I get triggered. But I know that I just need to take a break. I think, and then I'll be ready back on for number. What are we on? Number 9.
We're
Number
on
the
number 8, so
next
yeah,
one
we'll
is
come back.
number 9.
And if there is anything you feel like I've done that is triggering that you want me to check myself on, you
No,
can feel free to let me
it's
know.
not you. You're doing great.
All right.
You're doing
Well,
great.
don't
I just need to
hesitate to
take
let
a
me know
break.
if there is something, because I mean, going back to what we were talking about like a few days ago about like there's different learning styles, different people learn differently. Like if you feel like there's something that I'm doing or could do in a different way that you would prefer, like I just hope you feel comfortable like talking to me if there's something that I could be doing better to help you better, or if there's something I'm
No,
saying like let me know.
I think we just need to I think I just need to draw it out like a little kid.
Okay.
I just need to like draw out like color, you know, yeah. Yeah. I'll do it. I'll take a picture and then I'll show it on the next one.
All right. Sounds good.
So what's the next one then? When can we do the next one?
I'll be available in the morning tomorrow. So I am going to Big Bear on Sunday.
Oh
So
yeah, that's right.
tomorrow night, yeah, I'll yeah,
And I
if
have
we're
my
gonna go
show tomorrow.
tomorrow, yeah, so if we're gonna go tomorrow, I think it'll need to be a morning one.
Okay, cool.
But we can
Okay,
text
cool.
about
So
it, and we
maybe
can
like
probably
10.
later
What
today
time do
too.
you what time do you wake up? Or like is 10:10 too early?
I think 10:10 would probably be good. Is that
10:10?
does that work for you?
Yeah.
Okay, sounds good. Then yeah, we can aim for that.
Okay, cool. 10, 10,
All right,
11, 12. Yeah, perfect.
nice.
I think 12. Yeah, that'll be good. Okay, well that was overwhelming and I'm gonna just chill, eat something, relax and draw out something and then I'll take a picture and I'll show it in for the next time when I feel a lot better about it.
Sounds good.
Thank
I'm
you,
very proud of
Jacob.
you, Laura.
Thank you, Mr. Harkey. Thanks.
Of course, anytime.
We'll get through this.
Sure will.
Learning and loving, even if it's suffering.
And thank you to everybody in the chat for the kind words and positive encouragement.
Yes, thank you guys. See you soon.